So similar triangles have congruent angles and proportional side lengths. The proportional side lengths, we will have the same, the proportional side lengths will have the same ratio. So this is something that we're kind of reviewing a little bit here, because we're going to go through and use our tools to actually move this triangle onto this one. So we can't fully do that on paper, but I can kind of show you what it looks like. So you can see the red triangle, I highlighted them both, so you can see they're the same shape. The dotted one is just, slightly bigger. So what we want to do on this one is just prove that the angles are congruent for each one. And seeing, this angle is congruent, and I can scooch this one down, and this one would be congruent, and I can scooch this angle down, and it would be congruent to the Z down here. So we just want to match the congruent angles, and then we want to match the side lengths as well. Okay, so with this one, angle G, we can see that's going to be down here with angle Z. H is up at the top with Y, and I is off to the left with X. So those would all be congruent. And this will be a little bit easier when you're looking at it on ALEKS and you actually get to dilate this triangle to match, and it matches up perfect. Just be aware it doesn't drag the letters with it. So if you have to rotate it all, you have to kind of keep a visual, I guess, in your head of where these vertices are. So then we have ZY over GH, and we just want to put the actual amounts in here. So ZY is 21 over 12 for GH, and we want to reduce that because they can both divide by 3. So 21 divided by 3 is 7, 12 divided by 3 is 4. And now YX and HI, and you can see I've highlighted these ones green. So YX is 42 and HI is 24. And again, we want to divide these down, and these can both divide by 6 in this case. So 42 divided by 6 is 7, and 24 divided by 6 is 4. So yay, we have the same ratio and the same ratio. We want to make sure that last one does also have the same ratio. So our very last sides here, we have ZX is 49 and GI is 28. And we can divide both of these so by 7 again, so that we can reduce them down to 7/4. Because if I divide by 7, I get 7, and 28 divided by 7, I get 4. So they do all in fact match, and the angles do match up. If I was able to kind of mess with this a little bit more interactively, I would be able to see that very clearly, because I could literally slide it over into the same corners here. So we either select that they are similar or they are not similar. Well, because they have congruent angles and all the corresponding sides are proportional, they are similar. So that was just using our proportionality or our similarity rules for polygons to determine whether or not the triangles were similar. I hope that helped, and I will see you in the next video.